So what have we just covered now? We've just covered, or rather learned, that the general formula or the shortcut formula or the general term of an arithmetic sequence or a linear sequence is given by Tn equals A plus n minus 1 d. Now, from today onwards, you're going to write it like this. Do not change it. Tn equal to A plus, instead of you having the letter D at the end or behind the brackets, put it there. It doesn't make any difference. Let me show you. I'll give you an example. Do this on your calculator. Go 3 minus 1 times 2. It still gives the same answer as 2, 3 minus 1 like that. I took the 2 I put in front. You still get the same answer. It doesn't affect. It's just when you're timesing two numbers, you still the order doesn't affect the answer. That is the commutative property of multiplication. You guys know about that. Commutative properties, associative, distributive. Are you guys happy with why I made this thing like so? Why am I doing this? Because it is always nice and convenient to deal with this whole calculation when you've got the D at the beginning. Because sometimes you may forget this and it just messes up with your mind. Rather, have it in front. Are we all happy? Right, so yeah, it's good. Yeah, we're all good. So now we're going to use this from this point on. Now you guys remember from our previous calculation or the calculations on T100 and T77, we did use this formula, right? We did apply it and got 299 and 230, right? We just substituted it from the general formula itself. You can actually simplify this whole thing. Like you can simplify this formula for a specific number pattern or for all linear patterns. How? You just simply go, before you even do the calculations, you just simply go, let's use a different color. Tn, substitute A. A is the first term, that is 2 in this specific sequence. Our D is 3. And you just simplify this. You go 3 times n, 3 times 1. So it's going to be 3n, that is 3 times n, and then 3 times minus 1 is minus 3. Okay? And then after that, you put like terms together, 2. You take this 3, put it next to the 2 because they are like terms now. Whenever you are moving around like things to match like terms, right? They move, the numbers or the things that you move with the signs in front of them. So now, since I want to move this 3 and put it next to the 2 because they like terms, it vies with the sign in front of it. It vies with the sign, that's minus. So it's going to be 2 minus 3. It vied with this minus. And then this one remains with the sign in front of it, so that's plus 3n. This gives us minus 1 plus 3n. So conventionally, or like normally, when we have a number and like a variable, A, B, N, whatever, you always start with the one that contains the variable. So you start with the plus 3. Remember I told you they move with the sign in front of it. This one minus 1. Having a plus same is not having anything there. So therefore, the general term, instead of you leaving it like this and substituting when you do the calculations, it is always convenient for you to simplify it, substitute the A and the D, simplify it to this, and you know that this is the general term of this specific sequence. So now when you do your calculations, for example, when you're now looking for T100, it is just easy to substitute. It's going to be 3, then 100 minus 1 gives you 299. It's easy to deal with. T77, it's going to be 377 minus 1 there, 230. Do you see that it's quick and convenient? Proper stuff. Any questions? Questions, gray areas, concerns, birthday wishes, shout outs, anything? Okay, we're all good. Proper stuff. Sharp, sharp. Let us just quickly test this formula on this one. Let's just say this is T1, 2, 3, 4. This is T4. Let's substitute n equal to 4 into that formula and see if we actually get 11. Let's see. So it's T. We're looking for T4, member number 4. In place of n, we put 4. 3 times 4 is 12 minus 1 equal to 11. So this confirms that this formula works. So whenever you're asked to find the general term of an arithmetic sequence, or also known as the linear sequence, ne, you after finding it, ne, you can just quickly test what you're already given and then see if it's actually like the right one. Then you know for sure that you would have gotten your full marks. Delicious. A quick warning for the exam. If you get into an exam, ne, and you have to do such a calculation, ne, you're here now, ne, you're at 3 times 4. You do not need your calculator to calculate 3 times 4. Because you already know from grade 1 that 3 times 4 is 12. Do not use your calculator and say, I'm just checking just to make sure in the exam. Because you know almost in the exam, there's a lot of pressure. You feel that air of pressure, ne? Like it's there. You understand what I mean? But do not fall for that thing. When you come across this, you use your calculator. It is always 12. Whether you're under pressure or not, 3 plus times 4 is 12. I said this last week. The moment you take out your calculator and punch 3 times 4, it is a demon trying to enter you. That moment you're gonna press 3 times 4, ne? That moment you press equal to and get the answer 12, the demon would have officially entered you. But if you resist and not press equal to and just use your brain to get this, then the demon will leave you. The same way the devil left. Okay, let me not preach. But yeah, you guys get the story. Please don't fall for that thing. All of you, I know that you've done this before. Don't ever do it again. Sharp. We're good now. Now, a question could come and say, a question could come and say, it's a question in the exam. 11 is a member of an arithmetic sequence. Remember that arithmetic just means linear sequence, ne? It's the same thing, linear sequence or linear pattern. 11 is a member of an arithmetic sequence with general term, the general term Tn is equal to 3n minus 1. This is the question that you get in the exam. You're not getting a list of numbers. This is what you're getting. 11 is a member of an arithmetic sequence with general term Tn equal 3n minus 1. Find n. Now, what are they looking for? They're just looking for the position of 11 in the pattern. Let us cheat quickly just so you guys understand what I mean by this. We know this is the pattern they're referring to because we already seen it. We already worked with it. And we know that 11 is member number 1, 2, 3, 4. Right? So n is equal to 11. So that's what they're looking for. Your answer here would be n, sorry, not n equal to 11, sorry. 11 is member number 4 of the pattern. So therefore n is equal to 4. It is positioned as the 4th member of the pattern. So that's what they're looking for. So your answer after doing your calculations will be n equals 4. Do you guys understand what this question is looking for? Confirm, please, all of you. If you don't, please ask me the question or you don't quite understand. Okay. Okay. When did it start? When did the connection problem start? I just want to make sure that I don't lose you. Quarter past 12. Okay, that's 15 minutes ago. Then I'll just quickly do a young summary for you. A young short. Were you? Yes. Were you there? Were you there when we calculated this 299 and 230? Okay. All right. So do you know that this is the formula for a linear pattern? Okay, proper stuff. And you understand that this is A means the first term and D means the constant difference. Yeah. Okay. So I gone ahead to ask the class to find me a T100 again. T100. But before I asked for T100, you remember I asked for T9 and them, and then you guys just sort of added 3 all over until you go to T9, which was very easy to get to, right? But now if they ask you to find T100, T10, 11, 12, and so on until 100, which is time consuming, right? So Yale, the mathematicians they came up with this shortcut because they worked it out and came up with this shortcut to find it, and then you know how to apply it. We applied we applied this formula for T100. In place of A, we put 2 because that's the first term. In place of D, we put 3, but obviously in place of N, we put 100 because that's what we're looking for. We got T100. So that's what we did. And then after that, same pattern. I rewrote the pattern because what we were working on was very dirty. So I just rewrote the thingy again, and then after that, wrote down the formula. Right. What I said was that rather than having the D there at the end, rather than having it there, put it at the beginning because it is always convenient to have it at the beginning. You know how awkward it is to calculate something like this? 3 minus 1, 2 there at the end. Rather have it like this. You see. This and this will give you the same answer. So I just simply move the 2, put it there. So there's no crime. I'm not changing anything by taking this D and putting it in front there. Do you see what I mean? Proper stuff. Sharp, sharp. So I was like, guys, from the previous 2 calculations, when I asked you guys to find T100 and T77, you just simply apply it straight from the formula. But it is always nice for you to just simply start from here. Start from here, from this, and then instead of you substituting T100, just substitute A and D first. So my A get 2, my D get 3. Simplify until you get to this point, Tn equal to 3n minus 1. So from there, then you can substitute n equal to 100 or whatever it is. It's always nicer that way, as opposed to just putting 100 there, 2, 3, 100 there. It's just a bit messy. Happy? Welcome. Charlie, okay, Charlie Hape, sharp, sharp. That's a nice summary. I did it within 2 minutes. Okay, Fere. So yeah, sharp, sharp. Now, I'm giving you an exam style question here. The exam style question says 11 is a member of an arithmetic sequence. 11 is a member of an arithmetic, also known as a linear sequence. Sharp, sharp. With the general term, Tn equals 3n minus 1. Fade. So that is them having simplified the Tn for an arithmetic sequence, having substituted A and D. Find n. So what is the question looking for? We know whether they're talking about this sequence because we dealt with it. So we're just cheating. We know that 11 is member number 4 of the sequence. Again. So your answer will be n equal to 4. That's what they're looking for. They're just looking for the position of 11 on this number pattern. Are you happy? Do you understand the question? What the question is looking for? Proper stuff. Now, since in the exam, you won't have that sequence itself. You won't be able to see what 11 is member number 4. You're going to write this thing down, right? Since 11 is a member, in place of Tn, you're going to put 11, like that. Now, from here, you're going to solve for n, the same way you solve for x. Whatever value of n you get will be the position of 11 in this number pattern. Let us go ahead and solve for n. Remember that the aim is for us to be left with n alone on one side. Be it on the left or right, doesn't matter. You're not violating any rule. So you must get rid of all of the numbers surrounding n. The first one you get rid of is not this one that's literally next to it, but it's the one that sort of adds or subtracts. You take this one to the other side, you transpose it, and when it goes to a foreign land, it changes signs. It becomes a positive. Then this will give us 12 equal to 3n. Remember that we're looking for n and not 3n. We want to have n equal to something. We have to get rid of this 3. The only way to do so is if we put a 3 at the bottom so that they can cancel. What you do on one side, you must always do on the other side. So we have 12 divided by 3. Therefore, n is equal to 4. Okay, even if you write it like this, still fine. There's no crime in that. Writing it like that, there's no crime in that. There's no crime in that. Cyril equal to cupcake, the same as cupcake equal to Cyril. 4 equal to n, same as n equal to 4. So leave it there. Don't try to, leave it like that. You guys happy with this calculation? All of us. Proper stuff. Sharp, sharp. So now, can you guys do me this question? Mm, mm-mm. Can you guys do me this question? Let's go. 1 minute. No, not 1 minute. 30 seconds. 45 seconds. Let's go. 45 seconds. Okay, any call to six. Let's wait 30 more seconds. Alles is klaar, ne? We're all done, ne? My Afrikaans are Japans. Let's go. So Barry, Barry 17 is a member of an arithmetic sequence, also known as a linear sequence. We all know that. With the general term 3n minus 1, find n, right? So we write down the general term as we have it. In place of tn, we put 17. We take the 1 to the other side because we want to have n alone this side. We've got 18 equal to 3n. Divide both sides by 3, n will be 6 equal to n. So what does this tell us, this statement? This statement is saying, 17 is member number 6 of the pattern that they're referring to. Since we already have the pattern, we know what it's this one. It's 1, 2, 3, 4, 5, 6. Delicious. Sharp, sharp. Let us give you a different question.